Hello, I'm Vivian Cheng. Today, I would like to present TexelBlocks. This work is done by me and my fellows from National Taiwan University. In this work, we would like to explore the possibilities of dynamic surfaces and, moreover, interactions that involve materials' spectacular physical properties. This is a picture of one TexelBlock. Each block is a basic component of a dynamic surface and can be plugged into a controlling board into a matrix of various sizes. Let's now take a look at a TexelBlock structure. The crawler belt wrapped around the block has material patches attached to it. In this prototype, there are 6 types of materials on each belt. Each type of material is sliced into thin pieces so that even rigid materials can rotate around the block. 3 gears drive the crawler belt, motorized by a servo motor in the center. The frame of the block is made by 6 pieces of laser-cutted 2mm acrylic boards. Lastly, there is an RGB sensor installed in the center for encoding. It recognizes the color marker attached inside the belt for the software system to know which material is presented on the top of the TexelBlock. We combine 24 blocks into a surface for the applications we want to explore in the work. First, we demonstrated a mock-up of a context-aware surface where users place beverage with different temperatures on the table, and the table dynamically switches its surface to the desired material that either absorbs the water from icy soda or insulates the heat from hot cocoa. Next, the touchable photo frame is where photos uploaded to our system get sliced into 24 pieces, and each piece gets categorized into matching textures. Although currently the capability is largely limited because we only have 6 types of materials. But we believe that in a future work where the resolution is enhanced and more materials are attached, this dynamic photo frame may propose more interesting interactions. The next application is the immersive storytelling. There are many children's storybooks featuring touchable textures along with illustrations. With a dynamic surface, any storybook or even videos, cartoons, can be expanded with rich tactile feedback. Next, we propose 2 kinds of gaming applications. First is an embodied role-playing game where the map is on a dynamic surface. The user taps the surface to indicate where to go, and the surface shifts the display map into a new region. There are capacitive touch sensors embedded into each TexelBlock. However, the rotation of the crawler belt interferes with the touch sensing. Thus, the touch sensor is not included in the final prototype presented. The second game is a physical board game based on the board game Monopoly. Each material around the board indicates different events. Each time a player ends a round, the path changes into random materials. Each player has an avatar and an HP bar made of polyurethane. When a player steps onto the sandpaper material, the player has to grind the HP bar on the sandpaper as a real physical form of losing HP. The avatar has an open circuit on the bottom, so when a player lands on a copper material, the circuit is connected and the avatar's eyes light up. This is an event of chance or fortune. Entering the chance and fortune event, random blocks on the game board switches into a mirror material. The player can use a laser pen to shoot laser onto the game board and see which block the laser reflects onto. Since the game is based on a Monopoly game, the user can buy estates to mark the player's territory. The player drops the liquid contained inside the avatar onto the universal test paper material. Each avatar contains different kinds of liquid that has different pH values. In the future, we would like to iterate through more generations of prototypes to enhance the speed and stability of TexelBlocks. We also would like to develop more working prototypes to evaluate dynamic surface of larger scales. We also want to dive into the unexplored artistical possibilities in the topic of dynamical surface. To sum up, in this work, we implemented a working prototype of modular blocks that can be combined into dynamic surfaces. Moreover, we demonstrated physical interactions that utilize the physical properties of each material itself. We envision a future where interactive surfaces simultaneously provide various tactile feedback and the spectacular physical properties of materials. Thank you.